Okay. So there's a little bit of a bait and switch here. I was talking about storing lots of conversation data earlier, and then I'm giving a talk about a database tool. We don't store conversation data in a relational database. There's probably too much of it to make that effective. So this has not got anything to do with storing conversation data like I was talking about. At Olark, in our backend, we use a service-oriented architecture or a service layer architecture, depending on how you look at it. The most important point here is that we're not using the database as our integration point across all our systems. So if one system is talking to another system, it doesn't look at its tables, it looks at its service interface, essentially. So this is something that we use, SQL Alchemy, for sort of individual projects with not a lot of sort of large relational structure in the database. So we have a lot of little databases. That's just one approach. Probably most people, I'd say, go the other way. They have one database and they have a lot of systems using it. Have some kind of domain model. They have some sort of service interface. Those objects contain a lot of business logic. There's all different ways to do this. But so we don't have this very thorough usage of SQL Alchemy, I would say. We kind of use it for basic tasks, and it's very suited for that, but it's also very suited for kind of more complicated tasks. What is SQL Alchemy? Let's get into it. That's what that slide says. That doesn't fit very well, does it? I'll have to deal with it. SQL Alchemy consists of two main pieces, which all deal with abstracting the database in some fashion. So there's a low-level core of the system that deals with direct interaction with the database. So I'll start by talking about the core. The ORM is sort of the more exciting part, the thing that I think more people want to use. It's a more kind of compelling part of the system. I'll get to that second. But so to start with the core is just a flexible tool for working with the database at a low level. There's no mega abstraction there. You work with actual insert statements that are sort of written in Python, actual create table statements, not dealing with sort of powerful objects that do a lot of abstraction. So the core does a whole ton of things. There's like 3-hour YouTube talks about what you can do with the core. It's a very, very sort of large system. It has a lot of capability to it. But you don't actually need to know that much about it to get going with SQL Alchemy. So here's an example using the core. This is just taken straight from their documentation. I've not done a lot of heavy lifting on this. You can basically see it has this table object it's constructing here. It passes in the table name, it passes in a metadata, which is this low-level thing you don't really need to know about, and then a couple of columns, and it's created a table. There's some other stuff going on in the background, but essentially once you've done this, you have a table in your database, and then you can start working with it, and then the line at the bottom there is just an example of inserting something. So you can kind of see this is not very far away from writing raw SQL. You can kind of picture the SQL statements exactly as they'd be translated. And it's not doing anything crazy behind the scenes either. It doesn't really know anything about these tables. You just have this table object now that you can work with. So that's kind of just a very quick example of what the core represents. Just directly interacting with the database as if you were writing SQL without writing raw SQL. So the ORM is the more compelling part of the system, from my perspective, for what I use it for. So if you don't know what an ORM is, which is entirely possible, some people don't, it's just a way of mapping tables and relations into Python classes or whatever language you're working with. So the whole point of the ORM is I don't want to write SQL. I want to work with objects, and I want to build business logic, into and upon around objects. And I don't want to have my business logic encoded in SQL strings or .SQL files that I have to run, and then if there's a typo in there, if there's anything that's wrong with them, it's just kind of gnarly to work with in the context of a greater Python system. So the ORM is all about giving you objects that you can work with. And here's an example, again, just ripped straight out of the documentation. Constructing, not actually declaring a class here. The table name has this private class level variable. User is the name of the table. And then it has two fields here. So these are columns. Again, you'll notice these are class level. These are not in the constructor. They're not self.id or self.name. So this is declaring the class with these columns and then the types of the columns. And so once you've done this, you have to run this other command that's not here. Put it in the oven, and 2 hours later you get tables in the database. So this is declarative. It's a little more comprehensible maybe than having actual create table statements or Python analogs that creates table statements. So there's a bit of abstraction here. And then you can see we have an object easily constructed here. Construct a add user, add user to the session, and when you commit the session, you have add user in your database. So super basic example, but you can probably immediately get a sense if you're not used to an ORM. You can put business logic in the user class, and then you can build other business logic outside of it and around it, working with it as if I only have objects and the database I don't even know or care about. That's all sort of handled for me, and I don't have to be concerned with it, which is kind of ideal. Cool, I put that slide in there to basically say what I just said. Okay, so I'm going to get into an example in a second. There's just a couple other things I wanted to talk about, which are the unit of work pattern versus active record. And then the last thing I want to talk about is Alembic, which is this awesome other tool. So I'll get to that in a second. So the unit of work pattern is, it means you've got a set aside set of tasks. That is, this is one thing that has to happen in a single transaction. So in your typical database scenario, you have a begin transaction, a commit, and a rollback. SQL Alchemy lends itself to that. Some other ORMs operate on an active record, which is just when you modify something, it's just changed right then, or somebody else that knows more about active record than I do can talk about that. But the difference here is just when I'm working with a unit of work, I have an explicit set of things that all happen, and if anything goes wrong in there, I roll it all back, as opposed to with active record, like I do a bunch of things, and then I imagine if something goes wrong, I have to undo a bunch of things. This is pretty close to the example I just saw a second ago. Creating a couple objects and then committing a session, as opposed to just having an object, make some changes to it and click save and hope everything goes well. So this is something that you see in the examples which I'm about to show you. And then the last thing I'll talk about is Alembic. No discussion of that here, I'll get to that in a second. But Alembic is just a really compelling thing, which if you're not already sold on using an ORM, Alembic might bring you over. So, actual working examples now, less talk, more doing things. From the start, you create the engine and you create a session. You don't have to do this, or this is for a very basic example. Here you can see this is creating a SQLite in-memory database. If you have a connection string, if you have an actual database, then you'll be doing that here. And then the next important thing here is getting the base. This is kind of a weird concept for me, at least, but it's basically just saying that, as I understand correctly, I want to use the ORM part of the system. this is pretty similar to the example I just showed, so I can kind of gloss over that. This is just declaring a class. This is the exciting part here. When I created the engine over here, I connected to the database. When you do this, it actually goes out and it takes everything that's constructed, everything it knows about so far, and it actually makes those changes in the database. So in this case, when you do this, it's creating a SQLite database at that time. And when you do this, it's actually taking everything that is connected to the base here, such as this user class, and creating those tables right then. So I'll show you what this looks like when you run it in a couple seconds.
Sure.
Sure. Oh, yeah, that's too. Did I look uncomfortable?
Yeah.
All right. And so the rest of the example is just going to be I constructed user, I added a session after that. This is very basic stuff. All right. And so I'm just going to run it here. Where am I? I'm just going to scroll up and show you all what happened here. So I constructed the engine here, and this is kind of off the end of the table there. You see the U there, the users. So here, this is what you're looking at here is just the create all statement in action. And so when create all was executed, it ran this SQL statement which you see here. So it really is just an abstraction around this DDL here. And then it's committed there. Okay. So that's, whoops, that's not what I wanted to show you. Let's go back to here. So the stuff so far is just everything up until here. And then what follows is just constructing a thing and working with it. So constructing the user there, okay, is just this right here. I constructed a user just like in the example. Not that exciting. And you can see here that if I, immediately after constructing it, if I check for its ID, it doesn't have one yet. So I've constructed it, but it's not in the database. I mean, given that the ID is kind of like an auto-generated auto-increment column. So the next step is adding user to the session, and still, when you add it to the session, it still doesn't get an ID there. It's only when you commit that it actually executes these statements and runs it in the database. And when you commit, it does a lot of exciting stuff. So you get a little begin transaction here, insert into users. Get the, I guess the user is inserted there. Those are the values it's passing into that prepared statement, I believe, and then commit here. And then it also has this extra query immediately after that. Okay, and then it's completed, and then after it's committed, now it has an ID. All right, so this little bit of code is abstracted, connecting to the database, creating a bunch of tables, inserting data, and then querying for it. And it's all, you know, very, very legible. There's not a lot of confusion about what's going on here. So, basic example of SQL Alchemy. How much time have I used already? Oh, geez. All right. That's not very good timing for a lightning talk. Okay. Well, I guess I'll wrap it up then. The only other thing I wanted to talk about is Alembic. Alembic, that's not going to be able to be read. Alembic is a database migration tool. So just as we have this declarative syntax for defining what the database looks like, you can also, if I can find the place where I want to be, you can also use the declarative syntax to do a diff on the database and see what's changed. And so if I look at here, I've just made a change to a model class here, to a database table. And so if I look at here, I've just added this column here, zerp zerp, for a trivial example. You can actually use a tool called Alembic to find out what's changed and then be able to roll back and forward between those two versions. And so just to show an example of that working, let's do, I believe, let's see, what's the one that current revision is, okay, so right now this is with the column added, and then I can do this, do an Alembic downgrade, and so now the database is at the previous version before the column was added. And then you can roll up and get to the column back. You can go up and down between versions. And so this is a really nice way of managing your database changes as sort of versioning the structure of the database. And so that's a really nice tool. That's one of the kind of primary reasons that we use SQL Alchemy itself, is so that we can manage our database changes nicely. Okay, so way over time. Questions?
Alembic is a plugin to SQL Alchemy?
It's another library that's kind of built off of it and uses all the stuff that's there. So it's like a separate dependency you pip install.
And was it following that head? Is that the Git head, or is that?
So it's got its own sort of set of versions that's kind of inspired by Git, I guess. You can see like it has these little version identifiers there. So that's similar, familiar concept, and you can even do branching stuff.
But they don't necessarily correspond to what you define in your Git.
Yeah, exactly. Yeah, that's totally separate.
Thanks, Dave.
More questions? Okay, good.
All right. Jaime is next, and he will give a talk on PEP 465, which is a matrix multiplication operator, I believe.
Yep.
All right. Do you have a HDMI thing?
No. Can I get
Does it have
the...
VGA?
Yeah.
Oh, all right.
Yes.
Also, I'm going to time you, but if you go over, don't worry too much.
I'll
It's okay.
think I
But
can
try
be
not
quick.
to go over too much.
This one's short. So this sets up, if anyone doesn't know, a PEP is a Python enhancement proposal. Okay, so if you want to leave your lasting mark on the language, you should write one of those, and if the Guido decides to accept them, it will go in, and well. So this started a few months back from the NumPy community. Matrices, which are basically two-dimensional arrays, are everywhere in numerical computations and the like. They're one of the building blocks of anything math, numeric on a computer. So they're really important. And there's a particular thing with matrices, which is that they have like two possible definitions of what a multiplication is. Okay, the fact that matrices are multiplied in a weird way should be no problem to Python, because you can overload the magic __mul__ method of your class and have multiplication be whatever you want. The same way that lists have multiplication defined to be concatenation. You can do a list times 3, and that's 3 copies of the list, which is a made-up definition for Python. But matrices have two ways, or two things that mathematicians have usually defined as products. There's matrix multiplication, which is probably the most used in mathematics, but there's also what mathematicians call the Hadamard product, which we would probably call just element-wise multiplication, which is also an important operation in everyday computing. So I've put here how do a few, MATLAB as the golden example of what a math package should do. Uses the asterisk, the typical multiplication operator, to do matrix multiplication, and it has a dot asterisk operator to do element-wise multiplication. NumPy, which is like the de facto standard of Python numerical computations, has two different objects. One is the ND array, which is the multi-dimensional array, which is its basic building block. It uses the asterisk to do element-wise multiplication, and it has a dedicated method, this dot method, that lets you do matrix multiplication. Okay? So you can do matrix multiplication, but if you have a lot of those chain, the syntax gets hard to read and confusing. Trying to work around this, someone came up with the idea, well, let's define a matrix class. That does things the other way around. We are going to redefine for this the asterisk operator to be matrix multiplication. And if we want to do element-wise multiplication, that .a method extracts an object of this class, and that sort of lets you work around this problem. Now the thing is that if you didn't know about NumPy matrix, and I've told you about it, forget about it. It's really, really bad. You should not be using it. If you're using it, stop doing it. It has lots of problems. It will. You may think it's good now, but it will eventually turn around and bite you. So don't do it. What PEP 465 proposed and what got approved, and it should already be in the beta versions of Python 3.5, is that the add operator will be made available, and NumPy will grab it and use it to mean matrix multiplication. Now this is hope that it will help push scientific users of Python to use the 3x versions. There's a lot of people, me included, we are still stuck in 2.x, and by adding an operator that should make sciencey things more easy to do, the hope is that more people will do the transition. For some details of the implementation, there are two operators defined, the matmul operator and the in-place matmul operator. There was talk of having a matrix power operator, which would be two add symbols, but that was decided to be left out. You are now going to be able to define new magic methods in your classes that will make use of these operators. And the operator has the same associativity as normal product. It's left associative, and it has also the same precedence as normal multiplication, as the standard asterisk product. One funny thing about this operator, I'm almost finished, yeah, is that no object in the standard Python library is going to use it. If you download 3.5 and you try to use an add on a list, on a dictionary, on a number, you're going to get some kind of error. I'm guessing it's a not implemented error that you will get. But it's there, and you can use it. And even though NumPy is going to use it for matrix multiplication, you can just get creative with this and do whatever you please with it, which I can't think of any other use, but well. Now the symbol may look a little bit awkward. Why would you use this? It's the only ASCII character available still, because there was talk, oh, we could use Unicode, but that apparently Widow is not going to have a non-ASCII code as part of the language. So really it was the only sensible option that was a single character, and if that's all that's left, that's what we get. And that's it. Questions? How much did I go over?
Not much.
Huh?
I don't know. I stopped it.
So if you say it was an incentive for people to move to Python 3x, does that mean they're not getting backported at all?
No, it's not going to be backported. You will not get it in 3.4 or 3.3, and definitely not in 2. Anything. Yeah. So, I mean, I don't think they're willing to backport, especially to 2.x. Nothing at all.
Is there any downside currently to using NumPy with 2.x?
I don't think so. I think it's just that we're lazy and we don't want to start putting parentheses around our prints. That's the only thing I can think of. The NumPy codebase should be version agnostic. It's like the same code runs in 2.x and 3.x. You don't have like different versions being compiled. The C code is full of defines that look at the version, but
so new NumPy users should probably try to go with.
Yes, and yeah, and you should try to import from the future, import division and import the print function and get used to it, even if you're at 2.x. But I mean, I know that I don't do it, especially the parentheses things around the prints. It's what keeps me from going there. But I wouldn't mind. I mean, it's really a small price to pay. Yep. So, all yours.
Awesome. And did I get your name? Andrea is going to present on pandas, which I am installing right now.
Okay. So well, pandas is installing. So yeah. Yeah. So I'm Andrea Zonca. I work at the San Diego Supercomputer Center. I do application support. So we help scientists use our supercomputers, and we have also a program for having industries use our supercomputers. So if you have any interest about using HPC resources, just get in touch with me. So pandas, it's a library for
I'm working on it.
Okay.
Oh, it has to install NumPy now? Oh, Jesus.
Yeah, don't worry. Let's use the static node. Okay.
Yes, it does.
Okay.
Yeah,
So I'll do.
I'll just put it over there. Or not. It's over here.
Okay. So okay. So here I have a notebook where it's a simple example of how to use pandas to load the CSV and do some modifications and take a look at the APIs. So I get this this data set, which has been used in the UC Berkeley data science class, which is just a log, some server log. So you see here. So basically we have some client IDs, and then we have dates, and then a file name in HTTP code, and then the size at the end. Okay, so you see here, for example, that there are some missing values, and the missing values are marked with just a dash. Okay, and so it's very user-friendly in pandas to just load this data into data frame. Okay, so what you just do, you just call read CSV. If in your data set you have a first line which has a comment, so dash, and then column names separated by commas, pandas can automatically convert them into column names. Instead here we don't have that, so we just specify the names we want to use here, and then we can specify a list of all the kinds of values that we want to transform into not numbers here. So for here we have just dash. Okay, and this is a data frame. Okay, and so it's just a multidimensional array with columns. The columns have name, and here this is the index. So what's the index? So we can create a data frame ourselves. And how do you do it? Basically, you need to specify a dictionary of all of your columns. So let's say, for example, for this data frame, I have just one column, which is my label, okay? And then I have the list of values. So you see here 1, 2, 3, 4, okay? But this dictionary can have as many keywords as I want, and these are gonna turn into columns in my data frame. And then this is the index. So the index can be, so the default index is what we saw here. So just integer, it's just a raw number. So the same thing you see often in NumPy. Well, but it can be any object, or generally it can be a string or a time, a data time object, and so on. So it's and this is basically used to access your data by direct indexing. So basically you can access your data frame like a dictionary, and this is going to extract either rows or columns. So So let's say, so we have this, this table basically, this data frame, so we can extract columns just by calling with dot and name of the column, so this is size. And what we, so the kind of data structure we get out is a series. So basically a series is similar to a NumPy array, so it's a one-dimensional data structure, and but the difference in pandas is that you have always an index column, okay? So this is, you see here, it's printing the size, okay? So here are all the values, you see the not the numbers we saw before, and then these are all the indices, okay? Then you can slice by row, okay? And here, you know, so it's can be a little confusing for pandas to understand if you want to slice by row or columns, and so there are specific ways of slicing. So here, for example, to get the first 10 rows, you just need to slice the .ix method attribute. Okay, and then how do you slice a data frame? So yeah, it's pretty intuitive, I think. So for example, let's say we want to have all of the data on first May 98. So we just do data.date. So we get the column, and when we do equal and our value. So this is going to be a series of booleans, and then we can just slice with the booleans. I mean, this is the same thing you can do with NumPy. Okay. Yeah, what is, I don't know if you ever used NumPy record arrays. This is similar because you have named columns, but this is a lot easier to work with. So let's say, well, you want to create a new column, you just slice this as if it were a dictionary, and you just give a new value, and this is creating a new column. So just like that. Okay, then you can drop not a number, so this is, for example, drop an A, and then you can, there's a specific function to datetime to transform a string of dates and times into a datetime object. So what we saw before here, they're just strings, okay, while here now we have a datetime column which is of type datetime. And with type datetime, we can do interesting manipulations. For example, we can extract the hour. Okay, so we just do a lambda here that gets the hour for each row, and then we use map to apply this to every row. And this is what you get. So it's just a series, and each of them is just the hour. Okay, and then we can use group by operation to group all of those data by hour. So of course we have 24 groups, and then it's simple to perform operation on this group data. For example, first thing, we can just count the number of rows in each of these groups. So basically the number of rows for each hour, and so this is a proxy for the traffic. Or we can so once we have this group, we extract the size, and then we do all the sum. So basically here for each hour we have the sum of all the size, so all the bytes transferred in each hour, and then we can just call .plot open close. This is automatically using matplotlib to produce plots. Okay, the most general way is to use aggregate. So these two are equivalent. So here is the sum method, and here we are aggregating, and then we can specify any kind of function. This function is just applied to every element in the group to provide our output. So these two are exactly the same. Okay, and then another useful method is histogram. So you can just do a very quick histogram of your data. You just call the .hist, and then you can chain multiple things to do more complicated stuff. Here, for example, I'm getting the URL, I'm checking just the JPEGs, so I'm basically creating a Boolean series here with just the JPEGs, and then I do the same histogram just for JPEGs. Okay. There's any question on pandas?
I don't believe that there are no questions.
to be honest. But thank you. So I'm going to go next. I guess it did finish installing all the things when you had about 1 minute left. Sorry. But I will...
So are people running projects at the Supercomputer Center using pandas, or is it usually like OpenCL that they're doing that sort of thing?
Yeah, there's people using pandas. The problem with pandas is that you cannot have distributed arrays. So if you are doing serial operation on each node, it's very convenient to use. But if you want to have something more complicated where you have distributed arrays and communication, then of course you need something else.
Does NumPy support distributed arrays? Or
no. What I use for distributed arrays is PyTriLinos. But there are other options.
What is it called?
PyTriLinos.
PyTriLinos?
Yes.
All right. Start. I'm going to go. My talk is on Python and XML. I was going to blow this up a little bit so that everybody can kind of read it. Okay, so if you've ever looked at the standard Python documentation on how to do anything with XML, you probably are already confused because there are like 6 different libraries that are all slightly different, and you don't really, unless you already know quite a bit about XML, you probably have no idea why you should use any one of them over any of the other ones. And the real answer is you shouldn't use any of them at all, probably, with some caveats. So the top 2 ones, Elementary and Minidom, these are 2 of the built-in ones. There are more built-in ones, but these are probably the most commonly used ones. Both of these are more or less DOM parsers, meaning they essentially read in an entire XML document and then perform operations after the fact. There is another type of XML parser, which basically reads the document as it goes. So it doesn't validate that the whole thing is valid XML, for example, before you start parsing and doing things. You might want this if your XML document runs into, say, the gigabytes. Because, you know, if you try to read in a 1 gigabyte thing and create all these objects for it, you will probably run out of memory. Even if you have like 16 gigabytes of memory, you will still probably run out of memory. You need more. So those are 2 of the built-in libraries. LXML is probably, it is quite an old XML library for Python, but also one of the best. Elementary, the built-in library, actually is ported from LXML. LXML is built on top of, well, the top 2 libraries are also based on C libraries. LXML is based on libxml2, which is a really common XML parsing library on Linux. It's very tried and true. It's you know, very fast. It performs very well. It's very standards compliant. It does a lot of things that you would want to do. It is faster than the top 2 and more complete for most of the operations that you would want to do. It can do things like validate an XML schema, which the top 2 cannot because, I don't know, I guess the XML library decided that they didn't need those types of things. It is also reasonably secure and can be made more secure. But yeah, I'll get to security in a bit. Another thing that I see quite frequently, boy, this is kind of hard to scroll, is people use Beautiful Soup for parsing XML. This is Beautiful Soup 4. I'm going to talk about it briefly. This is an HTML parsing library. When it parses XML, you can tell it, you know, parse XML, and it actually relies on LXML. If you tell it you are parsing XML, if you tell it you are parsing HTML, it will not be validating. It will not check that you have a valid XML document, because most HTML documents are not valid XML documents. Anyway, I'll talk briefly about that. It's a third-party library. I generally don't recommend it for parsing XML. It's fantastic for parsing HTML. Diffused XML is another third-party library. This is basically the library you need to do if you need to parse untrusted XML. If you are parsing untrusted XML and you are not using diffused XML at all, and you don't know what you're doing and you're using LXML, which, you know, if you know what you're doing and you're using LXML, you might be okay, depending on the situation. If you're not doing either of these things, you are doing it wrong. And I will show an attack that will easily crash whatever program you are running. And then the last thing that I'm importing here is just to help me do things. The request library. All right, so first I'm going to get some data. This is from the Major League Baseball website. that powers Major League Baseball's like mobile app and everything. It basically is all the games that are going on today. And I'll show you sort of what that looks like. So it sort of is a scoreboard. It has a date, last modified, which is empty for some reason. And it has a number of games that are happening today, things like the league, National League, what's the status of the game is over, when the game started, 2:10, which I believe is in Eastern time, talks about the teams, talks about how many runs, how many hits, how many errors they got, those types of things, whatever. It's an XML file, fantastic. Major League Baseball has literally an XML file for every single game that has been played in the last 30 years, and every game played in the last maybe 5 years. There's at least 10 data points on every single pitch in the game. I'm serious. If you want the data, let me know. So this is Elementary, one of the built-in XML parsers. Holy crap, I'm down to 10 seconds already. Fortunately, mine is very fast. This is just a very simple example. It loops over a number of game elements and prints out a bunch of attributes for the game elements. That's about it. That just shows an example of it. This is more or less the same thing with the mini-DOM library. Pretty much, the syntax is very similar. It's not very Pythonic, I think. For small files, it works fairly well, as long as they can be trusted. This is LXML. You could do things like, I want to validate this large XML file against an XML schema to make sure that the data is what I'm expecting, things like that. It also, the elementary library supports XPath as well, but LXML supports more features of XPath. But you can do things like, I want all the National League games. So you could say, get me all the games where the league is the National League. And then this could get a bunch of things. So you can see all of these are National League games. Pretty useful. Beautiful Soup, same type of thing. You can do a soup.findAll, get all the games, get a bunch of game objects. It supports CSS selector-like functionality, which is actually quite nice. Although when you're using XML, probably XPath, which we saw earlier, is a little more standards compliant. If you're using Beautiful Soup 3, Beautiful Soup 3 performs like absolute garbage. It is not implemented in C. It is 2 orders of magnitude slower than every other XML parser that I've shown you today. Yeah, if you try to parse even a 1 megabyte file, it'll take you 30 seconds. So this here is sort of the security thing that I talked about. This is also my last section, I think. Basically, this is an XML file. In XML, you can define elements. You define your own custom elements and what they mean. And in this case, basically, I've defined an entity lol, and then I've defined an entity lol1, which has a bunch of lols, an entity lol2, which has a bunch of lol1s, an element lol3, which has a bunch of lol2s. You can see this is basically exponential. This is about a 1 kilobyte, maybe, XML text string. If this were to expand in memory, hundreds of gigabytes. It'll crash whatever you're running. If I were to just run DOM parse string, this would be from the mini DOM library, it'll crash immediately. Like my computer will run out of memory literally in seconds. If you are accepting XML through a web service, for example, your web server will crash immediately. It'll get terminated by the kernel. Yeah. Anyway, so basically, there is no way to parse this XML document safely with the standard library of Python. It cannot be done. Insert the diffused XML library. Basically, they have safe versions that are monkey patched, which we will see in a second, of all of the standard library Python XML parsing libraries, as well as LXML. So if I were to do this, this will just throw an error saying, entities aren't allowed, basically. I don't think I actually ran this thing. So if I run this thing, and then run the next one, then I think I see it. Entities forbidden, huzzah. So you sort of see, like, you can actually say these entities are allowed, these entities aren't allowed. It's flexible, but basically it's the only way to parse untrusted XML safely. And that is my entire talk. I went over slightly. Trey is next. And Trey, what did you need me to set up for you? Anything?
Python shell.
Just a Python shell.
David, so when you say that untrusted XML will crash your system, are you talking about it doing Stack Overflow that you can't even trap?
It will basically allocate memory until you have no memory left, period. Not even on the stack, on the heap. So like you will consume, you know, I have 16 gigabytes of memory. It will consume 16 gigabytes of memory, all of it.
So
With LXML, you can do things like, here's the maximum amount of memory that you can allocate before it just fail to parse. You can do things like this.
Were you saying that you could use diffuse with LXML?
Yes.
Okay. So
There,
it's just
it
like
works
a
with
small
all the standard
multi-patch
library. It
thing
works with
that-
LXML as well.
Alright.
And it works with XML RPC too.
So you talked about Beautiful Soup 4 being fast.
It
compared
basically uses LXML when you
Right.
do XML
to-
parsing.
So does that make PyQuery obsolete?
No, I mean, I don't know, maybe.
Do you know what PyQuery is? It's like
I've heard
sounds
of
a few
what
on
Google
GitHub, by
does,
the way.
jQuery style selectors built that use LXML. essentially, web scraping.
I mean, I haven't done it before. I have done things like that, but I mean, typically when I do XML parsing, I use XPath. But, you know, to each their own, I guess. I don't know what the performance capabilities of it are. The performance of LXML is very good.
So, David, what would you recommend for pretty printing XML?
I think actually a number of the standard libraries have something like that. Have
Element
something
3
for that.
is crap. It will print it without any indenting, any average return.
I think both LXML and definitely Minidom have something
How do
for
you
print.
flip the colors?
Okay.
Black
What?
and
Do
white.
you have to?
How do you make it like black?
You
and
have to
white?
like go to the profile or something. It's in the preferences.
So one of the key points
it.
with LXML
Apple
is that,
U.
you know, it has system library.
That what you're looking for?
dependencies.
I don't know.
I was just looking to make it more readable, maybe like black and white and bigger font or something.
Oh.
Or at least bigger font.
Bigger font.
Okay. Okay.
Sorry. We'll talk after. Any other questions while Trey is doing?
Okay,
Trey's ready.
so
Trey's ready.
I am going to talk about monkey patching. So monkey patching is a way to, well, whenever you modify or extend code at runtime, that's monkey patching. I think this is best shown by demonstration, so let's do that. So I'm going to make it so the print function does not actually print to the screen.
Should we increase the font a bit more?
Yeah.
Yeah,
It's Apple Plus.
Apple Plus.
Okay,
Okay.
cool, much better. Thanks.
Okay, I'm importing string IO and sys here. And can you see that out at the bottom? Okay. And I'm going to store sys.std out in a variable real std out. And then I'm going to set sys.std out equal to a new string IO instance. I'm going to print out to the screen and you will see that nothing prints. So let's take our real std out instance that I stored earlier and write to it. Alright, there it is. So it actually stuffed that into our string IO that we monkey patched, the sys.std out to be this string IO thing. So we can print and nothing happens. So to restore it back to normal, let's change sys.std out back to our real std out. Should run this on my computer. Alright, now print works again. Okay, so that's kind of weird. What would happen if we change sys.std out to like none or something? Any guesses? Yeah, but what will it actually do?
I think it'll throw an exception.
Yeah, I think it's a traceback error. Okay, so none type has no attribute write. So print is trying to write to sys.std out. That's what print actually does under the hood here. So when we patch sys.std out with this weird string IO object we've got here, it makes print do something else. So I've got this utils file. Oops, that's not the one I wanted. What's the other file? IO patch. So this is a context manager I wrote that it takes in a file name, opens the file, sets that self.fake std out to that file stream, opens it as writable, and then when you enter the context manager, it sets sys.std out equal to that file stream, just like we did with string IO here. And then when you exit it, it closes the file stream and then sets it back to normal. So let's see what this actually does in practice. From IO patch, what was it? Print to file. Thank you. With say test.txt. Oops. Okay. So that printed nothing. Now let's open test.txt and read it. Okay, so test.txt has hello in it. So this is kind of cool. We can actually capture print and stick it in a file and look at it later. So what is this good for? That's the real question. So monkey patching, this is kind of dangerous in production. You don't usually want to do this because it messes with all sorts of code in your system, but it's great for testing. So if you've got a command line utility, for example, that prints out to the screen, you can capture it in a file and look at that later. Okay, I've got about 30 seconds here. In that time, I will show you. So this here is utils. There is a day of week function. It returns the day of the week. One thing we could do is we could change date in here. Do you have mock installed?
Just install.
Okay.
You're in a VM.
That was good. Okay, there's this cool library mock that has a utility called patch, and it allows you to change stuff at runtime, kind of like we just did, but a little bit easier. Oops, I already did that. Where was it? From utils, import, I think it was day of week. So this function is supposed to return the day of the week. The problem is if we're testing this thing, we don't want to have to know what today's weekday is every time we run it. And so we're just going to make it always return whatever the weekday is supposed to be on like June 22nd, 2014, which was a Sunday. So in the utils module we have, we're going to patch date. We'll call it fake date here. And we're going to say fake date, oops, not dot now, dot today, dot return value equals, oh, I didn't import date, did I?
No.
Oh well, this is going to fail. Let's import date. Okay. We're going to print day of the week, and it should be Sunday. Weird. Alright, now let's print the day of the week and make sure that it should have reset it back to usually. Okay, Thursday, great. Okay, so that's monkey patching. Kind of weird. Any questions?